We're going to learn a bit about graphing slope fields on the TI-89. There's a lot more that you could do than we'll cover in this video, but it will give you enough to do some simple slope fields. If you wanted really precise graphs, I think you would use a computer application with a better resolution. Right now on the screen there are some notes that you might wish to return to later. They would be a good reminder, but I don't think they're going to make a lot of sense to you until you actually see this in action. So let's grab your TI-89, and you should pause the video along the way to complete each step that I do. So first, all we need to do to graph slope fields is to use the Mode menu, and we want to change from our normal function graph to a differential equation graph. So use your right arrow and choice 6. So differential equations mode, and you'll have to change that back later. When you change an entry in a menu, remember it's not saved until you hit the enter key one more time. So now we're going to go to our green diamond y equals screen, and you'll see that it looks very different. So instead of function y1, it now says y1 prime. So this would represent a dy dx. You see a big change here that there's a letter t. So instead of the variable x, we're going to convert every x into the letter t when we enter it into your TI-89. All right, so my first function, my first differential equation is dy dx is equal to x minus y. So dy dx is our y1 prime, and our x minus y, when we enter it, we have to convert every x we're going to enter as the variable t minus, and if I just put variable y, on your TI-89, there is function y1 and function y2 and y3. So we have to tell the TI-89 that we want our y variable to refer to y1. So this is the derivative. Okay, so y1 prime of t is t minus y1. And hit enter. And I'm going to go to F1, our tools menu, and you don't have to do this every time. This is hard to remember because it's choice 9, so it's not visible. So scroll down. It's actually at the bottom, so you could scroll up to get there faster. And you can experiment with these choices later of showing the grid or not showing the grid, showing the axis. You don't really have to worry about those. I think we like these settings. But I wanted to point out there are two methods your TI-89 can use for slope fields. This RK for Runge-Kutta, or we could choose Euler's method, which BC Calculus students study. But all I want to change at times here is to make sure that the field is turned on. So yours is probably already turned on. The last thing I did with my emulator, though, I had the field turned off, so let's go investigate there. So slope field is choice 1. So I want slope field to appear, so make sure that it says slope field as your choice right here. And yours probably already did the first time you get there. And now we'll hit enter to save. And then before I graph, I'm going to choose the window size and one of the zoom features. So F2 zoom, oops, I hit window instead. Let's do F2 and choose zoom decimal, choice 4. This is sometimes called the easy screen. It increments by decimal values, so it makes a nice slope field. You don't have to worry about that. You could set a different size window if you prefer, but that's how quick it would be to get a slope field on your calculator, much faster than all that arithmetic. So you would not have to do the F1 tools the next time. You could just change your Y editor now. All right, how about putting some solution curves on the graph? Let's go back to our Y equals screen, and this stands for Y initial, YI1, Y initial value. And our initial value of our X variable, of course, is this T. So this is really T naught. Our 89 just can't do the subscript. So I want to do an initial curve through the point 0, 3. So our x coordinate is now our t equals 0. So all I need to put here in the y initial value is 3. And I hit enter. So this is an ordered pair for our first initial condition. We're going to sketch the solution curve through 0, 3. And let's go back to the graph and watch that happen. It's a little bit slow. It shows you the positive side first, and then it goes back and finishes the negative side. And now the problem here with this, why are we waiting? Why is it busy? Because the algorithm has to finish to check all of the values to the left here. So you can use one of the settings to make that go a little bit quicker, but we're okay here with the few of these we're going to do. Now I want to go back to the Y editor, and oops, I guess I didn't hit that. Let's go back to Green Diamond Y editor, and now let's show you a nice feature here. Let's clear our initial value for Y and show you that your TI-89 lets you put in a whole set of Y coordinates at once. So set bracket is above the comma key, and now I'm going to do 3 solution values. So I'm going to have a Y coordinate of -4, separate with a comma, and a Y coordinate of 0, comma, and that Y coordinate of 3 that we saw a minute ago, and then second key to close our set bracket. So all of these, our initial X coordinate is still 0, but we have 3 different initial Y values. And now when we go to the graph, we should see that it's going to give us, first, this is our solution point, our solution through 0, -4, and then 0, 0, and then 0, 3. And again, it's doing only the positive side first, and then we'll have to wait. It's going to go back and finish the negative sides. That's simply how the algorithm was set up in the programming code. So it looks busy, but it's actually checking to finish that first solution curve. We just don't see any visible points. There comes the left side of our second solution curve. And after it finishes, we've got some more to see on our third solution curve. And be patient while it finishes checking the entire axis. All of these values have to be checked as soon as it's not busy. So then we can see that there's one more way we can do some solution curves. So this F8, which I always forget where it is, it says IC, which represents initial condition. F8 is above the F2 function key. So I'm going to do second F8, and it lets me type in or use my cursor. So you could use your cursor to get to an initial condition. You can see that the value changes if I move the cursor. So you could just pick a spot by moving the cursor. Or if you know what value you want, and I want to put in a 2, 3. So if I hit the 2 key and enter, it gave me that T coordinate and -3 for the Y coordinate, and hit enter. So 2, -3, there's our point 2, -3, and it's showing me another solution curve. And then we'll add a 5th one here just so we have some reminder practice of how that F8 function worked as soon as we're not too busy. All right, so let's try it again. Second F8. And this time let's do a solution curve through -5, 3. -5, enter. 3, enter. And this is a good reminder that a slope field gives us a visual idea that every differential equation has an infinite family of solution curves. So for my students, you should pause the video right now and sketch that graph. You don't have to make it perfect, just a rough sketch so I know you're with me, in the first box on your homework paper. And then when you come back to the video, we'll continue. So our next process, let's go back to our Y editor and let's clear that initial condition. You could, by the way, just choose F4 and deselect y1 prime, and then you could have entered your next one in y2 prime, but we're done with y1. So let's put in a function that we could do the integral ourselves. So if I had dy dx equals x over 2, so remember I don't put in x over 2, I put in t over 2, t divided by 2. All right, so that's equation is our dy dx is equal to, and then t over 2, if we did the integral, we would raise the exponent, so it would become t squared. We would divide by it, so we know a solution curve would be t squared over 4, so it should look like a parabola. All right, and let's do some specific solution curves while we're here. Let's do 3 of them again. Let's do set bracket, and actually let's just do 2 here. Let's do a parabola through the point -1, comma, that's our y coordinate, remember, and then let's pick 2 and close our set bracket. And our x coordinate, remember, we haven't changed, is still 0. Next time we come back, we'll change that. So we know what this should look like on our graph. Our slope field should suggest that parabolas are the solution curves. And there they are. So again, you wouldn't need a slope field if you already knew the solution curves were parabolas. All right, so I wanted to do this so you'd have this verified. And then I want to go to the home screen and remind you that we could use the differential equation solver. And again, I wanted to do that with this function that we already knew what to expect. So in the home screen, catalog, and I've already been in the D's here a minute ago, so you could, when you hit catalog, it defaults to alpha, so you could just hit the D key down here to get to the D's instead of scrolling. So we get to the differential equation solver. You've seen this before. And I want to solve the equation y prime, or dy dx. So remember, we use y prime. The second equal sign is where we get the prime symbol. So that's our dy dx equals. And now I could use the variable t again, but I'm in a completely different screen here. So I could use x. Let's put x divided by 2 was our original function, comma, and then we need our independent variable x and our dependent variable y, close the parenthesis, and hit enter. So very quickly our TI-89 solved our derivative equation. And remember, the @ symbol shows you the constant. All right, this next part I want to show you isn't very helpful in my opinion, but we could draw a function directly from the home screen. I can't say that I ever really use it, so I'm going to, let me just clear this so you know we're doing something new here. So I'm going to go to the catalog again, and still in the D's, but this time I want draw function. Draw function, there it is. So from the home screen, when we draw a function, we don't need to put y equals because it already knows that we're drawing a function value. So I'm going to enter this, and I could go up and copy it, but I don't really want the @ symbol. So it's just as quick here to type x squared divided by 4. And for our plus c value, let's choose a specific parabola. Let's choose -3 here for our c value. And once you have this draw function typed into the entry line, when you hit the enter key, it does something quite amazing. It goes right back to your previous graph screen, and it adds yet another parabola. So the guys in my class, you should pause the video, and that's what you want to sketch, those 4 parabolas. I don't care about all of the tangent lines from the slope field. Just give me the general impression, so I know you completed this. And now I trust that you're back. We've got one more to do. So let's go to our Green Diamond Y editor. And this time, I'll clear that so you know we're going to change it. This time my function is dy dx is equal to e to the negative x squared. Dy dx is equal to e to the negative x squared. So I'm going to enter this into y1 again, and I'm going to do our e to the x key, but I'm going to change to negative t squared. So remember, every time you see an x, remember to convert it. When you're graphing differential equations, use t instead of x. And our initial condition point, this time I would like the x coordinate to be -3. In other words, the t coordinate to be -3. So I'm going to go up to our t naught and choose F3 to enter that, or to edit that, sorry. So I want -3 for the independent coordinate, the x coordinate, and then down to our initial y value, I want the initial y coordinate to be 0. So let me remind you what we're doing here. We're graphing the solution through the point -3, 0. So this is our x coordinate and this is our y coordinate. And this is a little smaller graph, so right away I'm going to use the window function here to show you that we can do that. So I'm going to change our x min, x max to -3, +3. I'm going to leave everything else. And I'm going to go down here to our y min, y max, and I'm going to make that -1 to 2 for our y min, y max. And there's only one other thing that I ever change here, really, I guess, and that would be this field resolution. It changes the size of the little tangent lines. So if let's go ahead and change that to 18. Don't make it too large because it gets cramped very quickly. So you will see that it just squeezes a few more tangent lines into the graph. And we're ready. Green diamond graph. So there is our slope field. And can you tell there's a few more tangent lines than there were before? And here's our solution through -3, 0. And there's only one more thing I want to show you, and that's back to our F1 tools. You can get to it from the y equals screen or from the graph screen. So I'm going to choose this F1 key. And again, it's very deceptive because all of these are grayed out, but option 9, so you can arrow up to get to it, or you can hit the 9 key. Now I'm going to turn this slope field off. It's still going to be there, I'm just not viewing it. So slope field, and I'm going to go down to field off. So why would I do this? I would do this if I want to see my solution curve, but I do not want it to be distracted by all of those tangent lines. I might do this if I now wanted to graph another curve on the same screen. So once I'm done seeing all of those tangent lines, then I can turn the slope field off. And that's quite a few features, good enough for one video. So this is the third graph that my students should put on their homework paper.